My name is Darcy. I'm from the Danbury Public Library and I want to welcome you to STEM at Home. This is going to be a series of short videos where we do little science experiments using stuff we have around the house. So today we're going to make kind of a lava lamp. And we're going to do that using some vegetable oil, some water, some kind of fizzing tablets for your tummy, food coloring, and a jar you can pull out of your recycle bin as long as it's clean. This one used to have tomato sauce in it. So to start, we're going to pour our vegetable oil in first. So move everything out of the way. So I want you to get a good look at what it looks like when I pour the vegetable oil in. So as you can see, it's going through, but it's kind of thick, isn't it? Especially the bottom. It looks kind of gloopy. Yep. That's because vegetable oil has a high viscosity. I'm going to want 2/3 of full. There you go. What viscosity means is that it's very thick. It's just a fancy word for thick. So our vegetable oil is a thick liquid. Kind of gloopy. If we stuck our finger in it, it would be kind of slimy and it would stay on our fingers and feel gross. Yep. So that's viscosity, which our vegetable oil has a high level of it. Our water, meanwhile, does not have as high viscosity. So we pour the water in. It's going to flow a lot smoother. But more importantly than that, I want you to watch what happens when I pour the water in. Now we're pouring the water on top of the oil, right? So the water should stay on top, you would think. But, as you notice, a little more in. What happened? As you can see, the water, which is clear, is on the bottom of the jar, and the oil, which is yellowish, is on top. So why is that? Well, that's because the water is more dense than the oil. The water molecules are tighter together, and that gives the water more weight. So even though they're both liquids, the water weighs more than the oil. Just enough so that the oil floats on top. And I bet if we take our little magic fork here, and we stir them about, you think, well, they're stirring, they'll mix up, right? So even though we mixed it, got lots of bubbles, but unfortunately, as you can see, the water and the oil still are not mixing. They separated out. The density of both of them are going to keep them separate. They're just not going to play well together. This is why when it's rainy out and the roads seem a little slick when your parents are driving or when you're driving, when you're a little older, that's because the oil that's on top of the pavement from all the cars going over, because cars do leak a little bit of oil, when the pavement gets wet, that oil floats on the surface. And oil, as we found earlier with the viscosity, is very slick. Yep. And all that oil that floats on top of the surface of the roads makes things slippery for cars. No matter how much we try and mix them, they just do not mix well. So that's part of our experiment there. That's the physics part. Next is going to come the chemistry part. And I'm a bit of a klutz, so I'm going to put this down because unfortunately my food coloring is gel-based and I have to mix it with water in order for it to work. If you have food coloring that is just water, liquid, you can just drop it right on in. So we're going to move this here. A little bit of food coloring. So now we have green water and oil. That's not very exciting, right? But here's where things get interesting. So we're going to take our little antacid tablets. These are the ones that make, when you drink them, put them in water and it fizzes and then you drink it down and it's supposed to make your stomach feel a little bit better. So what we're going to do is we're going to make that fizzy reaction happen. Put them both in there. And in a bit here, we will start seeing bubbles. And you can see them kind of coming up on the top here. They're floating around. So they're coming up from the bottom, those green bubbles. They're coming to the top and then they're falling back down. So what's happening here? The antacid that we put in is mixing with the water and it is causing a gas to form called carbon dioxide. And that carbon dioxide is taking little bubbles of air, and bubbles of water I should say, mixing in there, and it's hitting the oil and it's flowing that water up to the top with these little green bubbles. When it gets to the top, the bubbles burst. and then that green liquid flows back down. Now we got a lot of reaction going on, so now it's a little hard to see because there's a little too many little bubbles going off at the same time. But you hear that hissing sound? That's the carbon dioxide coming up to the surface and being released from those little bubbles. It's going shh, shh. Well, that's our chemistry part of the experiment. So we have learned today that oil is a liquid with a high viscosity. It's kind of slimy, it's a little thick. But even though it feels thicker and moves thicker than water, water has a higher density, which means it's heavier. So it will always separate and go under the oil. We also learned that some substances mixed with water can create carbon dioxide. Let's see what's in this stuff anyway. What is this made of? It's a very good question. What is this made of? It does not say. Oh. Active ingredient is sodium bicarbonate. So we mix that with water and a little bit of citric acid, and we get our bubbles. There they go again. So that is our homemade lava lamp. I'm using no electricity. So thanks for joining me today, guys. I hope you had fun. And if you want to make the experiment and try it at home and you want to take photos or pictures of it, you can share it with us at the library by tagging us on social media, either on Twitter or Facebook. And then we can see what you made, okay? And until next time, have fun, stay healthy, and we'll see you later, all right? Bye, guys.